Good afternoon, gentle readers. It's August 24, 2024, about 3:15 in the afternoon. Cooler, strangely so, given that the past 10 years have seen record highs every summer. We'll see how that is proceeding in pace. I'm not too sure if it's relevant to, for example, one of these volumes here called The Electrodynamics of Earth, the planet altogether, with regards to the magnetopause and the ephemeris of Earth about the sun, the source of all the thermal energy that it gets to it, vis-a-vis what it just emits and radiates away according to the thermokinetics laws of physics, laws of least action, laws of attenuation, laws of the existence of a gradient, which still has that as with regards to the first law of thermodynamics, and 1 unit of water's degree of contained heat or capacity to release or contain heat. And the second law of thermodynamics, or absolute zero, where there's none left. And it's as if the actual motion of kinetic energy at all stopped. That these two complementary concepts largely have, one of them having been picked out and made all the derivations so follow, which is sensible. It makes for the statistical ensemble, and it makes for like the CPEC and Peltier junctions between the electrical and the thermo. But it doesn't really get so much into saying, well, then our electrical is all quantum, and our thermo is as of the statistical ensemble or togetherness of a sort. So we kind of end up having to make it so that the electron, for electron physics, isn't quite so much electrons physics as electron anymore. That the physis of this is not the same. And it involves these conceits and figuring and sorting out that it's necessary to disambiguate what is otherwise these considerations that on the one hand are successful. They're simple and they're sensible, fungible, and tractable, and in their milieus they've been accurate, and on the other hand are kind of then making a victim of their own success. That although they're successful, then in terms of the other domains that are of relevance, it's not successful. That these are the kinds of things that then, for an overall holistic view of the things, where that everything altogether can be successful, involves a sort of rehabilitation to help explain the electron physics and why the quantization is a thing after the ultraviolet catastrophe, and to make for something like the muon physics or the neutrino physics. That's helping to explain why it gets back into why it's continuum mechanics again, and that even after all the stuff that went into the Copenhagen interpretation in the Solvay conference, or whatever you might want to talk about it, as of why it's determined that there's random quantum mechanics is behind all the things, that instead, again, it's just a causal and continuum mechanics. It's having been behind all the things, the sum of the histories, which resulted in the entire thing, the sum of potentials, which all adds up to theory of gradient, where then any thinking being, in accordance with all the means of the bounds of the limits of its computational ability, can have made any kind of decision as if with regards to modeling free will up to the moment, up to the instant, the same. Thus that we're given both fates and destiny and causality and the assurance of determinacy, and also the notion of free will and the idea that people are responsible for their own actions, and that they're also able to guide and direct their own actions. That these are just usual features of the theory. And it does take, though, that when some of the conclusions were kind of brought in, like, well, quantum mechanics' total randomness has erased any notion of causality and connectedness from the overall universe. It's like, well, that's too bad, because it didn't really, and it's just one of the theories among all the realms of abstract theories, none of which are necessarily continuous or connected at all. though that among all those that they are somehow all connected in the world of abstract theory, to then there's at least one theory, and for that matter, there can't be more than one, that is its own initial and final topology of a sort, this theory, a theory, the concrete theory, the reality, here's a stronger mathematical Platonist reality that is as well and at once also a science as for being a physics that pretty much takes the best of what we have as from physics today, which is general theory of relativity with space contraction and a Fitzgeraldian for the linear again, and the Galilean, Lorentzian, and rotational having its own milieu for Einstein's bridge, general relativity with regards to space contraction and the Fitzgeraldian, with the continuum mechanics, and after Bowman de Broglie for a real wave function collapse and interpretation, that then there's also this at least three domains of continuity, with mathematics bringing some more and further definitions of continuity that it needs, that it owes physics, these things. We have this theory of fall gravity in the middle, and that keeps the entire theory from at any point making itself as generating something from nothing, inventing this sort of perpetual motion and doing work from no input of energy or anything like that, and not just as some very contrived thing like the vacuum physics, but actually just saying that there's a violation of the conservation and of the laws of physics, gravity, that this fall gravity is about the only way it can work out, that with general relativity on one side and quantum mechanics on the other side, which have parted from each other about 100 degrees of decimal magnitude, to put them back together as the continuum mechanics on one side and the continuum mechanics on the other side, and as of all the linear degrees of freedom having just each their own, and the rotational ones being free in their rotation, and then all the linear systems and momentum and inertial momentum and mental inertia and frame spaces and space frames together again, because they're not together right now, and according to which direction they're pointed away from each other, that it's easier to turn them back around and make them a cohesive whole again than just forget either one of them and just recreate them with the same words with different things in there. So in moment and motion today, it's not so much different than the course as it's been since there was physics. Studying some ancient dusty philosopher from 1800 years ago or more or less, Boethius or something like that. He kind of splits up philosophy into these three kind of realms, and there's physis or physics. That's what's the natural, de re and de natura and this kind of stuff, and then there's mathematics and logic, and that's kind of, for him, that's like Plato's realm, and it's whatever, anything that can be is that the physics is substance, and then the mathematics and logic is like a thing, and then the divinity and deism and divinity, teleology is this third leg. And that's just like all the superlatives, all the sublime, outside, even this concrete, even this abstract, even this thing. So here that's kind of framed as like, well, there's a metaphysics, and that's still our physics. And deism and the divinity or that's just super scientific, because if it could be that this entire discourse is a message in a bottle or something like that. Not that it's considered that it is, instead it's considered that it's not. But because that would not be humble towards an even wider and more grand and more profound super everything. That's super scientific. Then, though, that the abstract and concrete mathematical universe make for a mathematical universe hypothesis, and that it really gets to helping define that actually this continuum mechanics must make it so that these plain numerical resources of the continuous domains define the very fundamental aspects of conservation of the invariance and the symmetries, making this continuity laws of the quasi-invariance and the symmetry flex for these running constants. and these other factors and aspects of big science that have been demonstrated in mega and giga and tera electron volt colliders since the 1950s, 60s, 70s, and 80s, and the big science of the day, and with the big science of the latest and greatest space telescopes in the sky survey, all adding up to one set of data, one theory, that Boethius's motion is described as things that move like this are physics. So moment and motion really encompasses a lot of what is the entire idea of what's the study of things that move at all. That's physics is motion, and then that the mathematics is things that are just like at rest and perfect somehow. And then that the deism or the theological side was like that's sublime to that. So in this manner, not so much changed, and that's always been the theory, and that's why we point to that and say that's the canon, and then the talking about here and me recapitulating it that's that much isn't so much saying much to that, except pointing out that of course that it's the latest and greatest of today's modern theories, reconciled, the rehabilitated, pointed back toward each other again, having a fall gravity in the middle, having this mathematics that's a replete continuum mechanics, having mathematics to be able to say that it's even a continuum mechanics again at all. That besides then having the silver thread still keeps a physics with the physics is not that big of a deal. What is it more of a thing is to say like, well, how about this infinitely many higher orders of acceleration? Coming, far, on, down, from the little end, from the least amount of the highest order of acceleration to 1/2, the hypercube distance equals 1. That's something that you don't find very much at all in the entire development. So that's been given to Zeno, basically, as to be number 5 or 6 of his arguments that need resolutions of their paradoxes, so they don't just leave it in a crazy place that has no explanations. There can be no paradoxes in logic. There are plentiful paradoxes in theories of all sorts that find any sort contradiction, whether in terms or evidence. Those are contradictions, and it can be said that it's a paradox that something is so and not so, or it is so because it is not so, and it is not so because it is so. That being the usual, most careful definition of paradox. Usually a paradox does not just mean any old contradiction at all. That just means either a mistake, a fallacy, a lie, or an unknown, or unstated assumptions, or otherwise that there's not the inference being complete, successful, full and fair, and accurate, true, right, and not wrong. Instead, a paradox is something that actually confounds itself. It conflates itself. It confuses itself as both so and not so, and that it's so because it's not so, and it's not so because it's so. So, in mathematical logic, the idea is that there are no paradoxes at all. What about a highest number like infinity? No problem. How about something that the sentence is not true? No problem. Not a paradox. Well, how can that be that the infinity equals infinity plus 1 is not a paradox? Well, it just goes to show you that then it's sublime, and then it makes for models of integers that are non-standard and extraordinary, superstandard models of arithmetic. How about this sentence is not true? One has written a piece of a sentence, a well-formed formula that implies its own inaccuracy. We'll just stop right there and let it rest for a second. Take a look at it instead of just reading it and necessarily saying that as I read it and the words rise from this, that they become their truth. Instead, this most simple method of quoting and then evaluating that inside just shows that it stops. It's that simple. And then when we need like an entire universe of truisms, this Comenius language, and then for the poesy and the metaphor that becomes a strong metonymy kind of This is Coleridge language. Comenius, though, for the guy who promoted education for the masses, and also came up with this idea of a true language where everything was true in it. That then it arises that this liar, the liar paradox, vanishes, leaving behind from this careful course of logic and reason about it a prototype of a fallacy, that which is false. So that then we can take that and relate it to anything else as a measure of otherwise that us pure, naive, innocent people who had no idea of anything to do with the lie at all would never be able to tell the difference. That's just an example of a prototypical fact without actually then engaging in this ex falso quod libe, facilis descensus averno, and all this kind of stuff so associated. We arrive back at again this idea is that we can still be true and as naive without being naifs and easily fooled in this course of getting to where we have a theory with no paradoxes. So there are some other paradoxes as with regards to mathematical logic. And so there's kind of like Russell's paradox, or there's Burali-Forti's paradox, Cantor's paradox. The idea being that a set would be its own power set, yet then they would relate by identity, but they can't because a power set is greater than a set. How can that be resolved? Well, it's simple. You just say that in a model where it's the primeval or elements or ordinals, and they have extraordinary ordinals, and then you have just the successor as the order type as the power set of this power set result, or this universal power set, and then it just makes for itself that it's okay, then its identity is like so. No paradox. Similarly for Russell, is like the set of all sets that contain themselves or don't contain themselves contains itself. It's like, yeah, it does. That's part of the sublime fact of the infinity of mathematics. It does contain itself. Its infinity is infinity plus one? Yeah, it kind of is. Yeah. So again, no paradox. So from working out this way, then you can at least get to a theory that otherwise would have to be all kind of broken open and apart and about and around. And people would say that then everybody will just have to make do with a universe where they just need to follow the last word they heard, which this ex falso quod libe, and consider that the truth, instead of having something which is with regards to that no matter what, they can take it or leave it as an objective realist's position that there is truth, and then from that basically ensure for their own purposes of self-interest, if you will, or interest in others. I mean, interest for this thing in its own sake, that it says the best the ontological commitment there can be, because it can never be wrong, because it's the only thing that doesn't have any errors in it. So these kinds of quests for reason and rationality, or res and ratio, for the natura and the re, the natural and the real. Of course, again, this is very, very, very old-fashioned. It's called the canon, and pretty much all the books over time, including the books that are largely treatises on religion, at least start this way to help explain philosophically how there can be anything at all, and how it is everything at all. And then with regards to whether there's the super of this natural, then that's of course given to this supernatural element, this super scientific element. But at the same time, it first answers the questions of like, why is there something rather than nothing? Or like, what is the word? When is the word introduced to our language? And that's a very important part of a philosophical text for the technical and logical aspects. Then also all the rest of it can be kept for its own brief ontological commitment to what that means, or its meanings, vis-a-vis its internalization, or its acceptance as writ and rote dogma, the canon and canonry of this kind of thing. You can take it or leave it, and it will be there when you get back. So what's hoped here then is to actually introduce something to be of value, to introduce something of novelty at all. Because otherwise you can just go find this not only at your local library, but on well-vested corners of the internet like the Wikipedia or the Stanford Encyclopedia of Philosophy, or courtesy a collection, or even just a survey or a summary of usual philosophical thinkers and logicians and mathematicians and physicists and scientists, what value there is here is offered is kind of like this. A, mathematics needs at least 3 continuous domains. It has only exactly one, called field reals, Dedekind completeness. It's been figured out that actually that follows this line reals, which is just between 0 and 1, like drawing a line, and that's continuity. And then the field reals is like, we'll take a ratio, and then you can make that as refined as you want. That's picking a point on a line, so field reals. And then the signal continuity is developing up, like much like Fourier analysis would be for Shannon and Nyquist in the signals and information, the theory, that mathematics needs and has these. So it's showing that mathematics has these, and then it shows that the theory for continuity's sake starts with these as primitive, primary, essential, and fundamental, as for this integer continuum under them, the integers, the natural integers, 0 to infinity, and then this long line continuum, which is like finally the initial and final topology of the long line that has for any other continuous domain that it will contain it. It's full. So these 5 definitions of continuity have one for the integer side, just not discrete, and the other one for the continuous side is like all continuous. And then in the middle that we have line continuity basically establishes that there's a non-integer part at all of numbers when there are infinitely many. And deductive argument is made that this must be, and it's so. And then field reals are so familiar to everybody. It's like, these are our arithmetics rules. Everybody knows them since first grade because everybody was taught them since first grade. They're great. Nothing wrong with them. Just not complete. Here we have foundations and everything all together has to arise. Finally, there's the signal reals, which is kind of like, well, what if, even though I can't tell the difference between a continuum and what could be just a discrete thing, that the limits of my perceptions are that all I can really perceive is that it's always a continuum. That kind of suffices to be a continuous domain, and that's kind of the signal continuity. So then the notions of the line integral, the Jordan measure, the time ordering properties, these things from physics to make these line rails, the complete metrizing ultrafilters, anything that's not standard analysis that's used to make these continuous domains. Like when category theory is just like, we bring our topoids in with 0, 1s, these are our domains, category theories, for example. Or a complete metrizing ultrafilter, this Dirichlet function, and the measurable character, the mensurability, the measure problem. This is a big deal in physics even since this last few years, because they've been working a drift, and instead of trying to fix mathematics first, because you have to kind of address the entirety of mathematics foundations at once, and physics needs that to arrive at this other stuff. So that's one thing that's kind of brought here is a richer and fuller foundations of mathematics. Now, why don't they already just have one of these? Well, it's been turned over a lot of times. Currently, the one that there is called Standard, the linear curriculum, and it's about it's great and it's full and it's got a lot going on, and you need to know it if you're going to be considered having the knowledge of these things at all. But it's simply not complete. and so it's basically it's kind of closed in a sense. It's like in physics when they found this Higgs boson, and they say, well, when we actually find the Higgs boson, then we'll have made sure that we'll fulfill the standard model of physics, where everything's bosons, these hadrons, and at the time that this was posited, it was still like 10 or 15 years out, where these bounds of supersymmetry could be reached. Then according to theory, it's kind of like the last rung they could ever reach. So all it would take would be all the investments of big science and billions of dollars and the super colliders and all this kind of stuff until, one day, 40 years later, they rolled up their sleeves and crossed their T's and dotted their I's and pulled out their slide rule and said, we're done. Standard model of physics is closed. It's done. And then they said, okay, well, so what are we going to do with all this super collider? And it's like, aha! Now the standard model of physics is done, and we've also proved that it's beyond the standard model of physics. It's like, well, what does that mean, physics boss? Well, what it means is now we start back over way in the 1950s and 60s, reopen the particle zoo, and start looking at every single one of these little things. Because what we didn't tell you about that was while we were like measuring our slide rule out to the Higgs boson, all this other stuff was still just living in its own muon physics and neutrino physics' world, where we continuum mechanics. So particle physics has been like, we've definitely stretched the ruler out 29 orders of decimal magnitude. And it's like, great. It's like, what is this thing here around the corner? And the guy just walks off. Is it similar with relativity and relativistic physics? Kind of. It's a very careful balancing act, because you don't want people to think that like tomorrow that that all this theory about like light speed would change or anything like that. Not that it does, but free information is free even if it's metered. That light speed is a careful meter, but it's in space, and space has got space frames and frame spaces in it. And so when they look at the sky survey again today, and they're like, up in the sky, my telescope sees there's a satellite or a wanderer or something that moves in the sky, a traveling star. And it's moving beyond a speed that it could have because the theory says it cannot. It's like, actually, the theory does not say that objects can't move faster than light speed. All it says is that light speed is constant. Mass energy equivalency then would imply that nothing could accelerate, given that there's the equivalence principle for gravity and acceleration to light speed, because its energy would appreciate to where it reaches infinity. The idea is that this space contraction of frame spaces and space frames does not leave that as so. So all the other mathematics are still very thoroughly satisfied, while at the same time the Galilean is the same. So when our satellites look out and see it, I see this highly dynamic thing moving faster than it's possible to say it does in our theory. Well, you can still keep all the reasons why there is a theory, where all the mathematical reasons why there is a theory, and have it so that it's explicable with a theory of relativity that's a total field theory. It's Einstein's still. It's got Einstein's second famous mass energy equivalency function that nobody knows, keeping that for the rotational and space contraction. That again, after the standard model of physics is all stood up, then there's all this what's left to even keep what's otherwise making it wrong, making it to where it's like, when we look out at the universe, we're quite accurate and sure that there must be this not luminous but yet not luminous matter and energy everywhere, both holding stuff together and keeping it apart. And we're absolutely sure there's nothing we can do about it because the numbers say so. And then it's like, well, there's a brief theory called fall gravity, and so you just end up putting that in the middle, and as long as that dials back in the center part with all the luminous matter, and that being contributing to making a shadow gravity or a fall gravity, a field of mathematical objects that make for the apparent field of the force of gravity. And then in the distant and farther that it drops off, on the scale of galaxies, that besides that they're rotating, and so once they get outside the rotating frame and they're basically far enough apart that they're free of each other, that then these other necessary reasons why relativity theory is not just like never been disproven, but it's got added on non-luminous matter and energy every year for 30 or 40 years at least. That is not scientific. That is not conscientiously critical anymore. So how to explain that is easily done with relativity, with field theory, it's total, and fall gravity, and then continuum mechanics for quantum mechanics. And agreeably, it will take quite a bit of retrofitting the same theory, which does have the successful bits. Of course, it's perfectly accurate, especially in all things in the classical, as long as you don't introduce any kind of complications to it. Where it is so, for anything that's purely fundamental and as of entirely theoretical and not at all empirical, which most things are. But then this idea of having that all one thing is a lot better. That's kind of how I see it. Is like all this theory has to have that, or something's wrong with it. And when I don't see scientists and physicists and theorists and logicians and mathematicians saying something about that, I kind of question their competence or veracity, one or the other. So you will find this, though. I mean, even like the most stellar people in the field, as of like Roger Penrose, he'll point it out. It's like, yeah, we got fashion, faith, and fantasy in physics, and these days we know that it's 120 degrees orders of both ways wrong, and then there's something along the lines of how to get that back together with regards to, do we leave in or out orthogonality or unitarity or complementarity or not, and you can't, and all these kinds of things. I mean, they've been trying to get over all these different ways to do it linearly and classically in a sense, but it's a super classical theory of some potentials, theory of some histories. It needs this mathematics better, and it needs this total field theory approach. It's got to be Machian, and so it's not like the field is ignorant this, but it's definitely so that like on the popular side, it's kind of like, proven right again. It's like proven what right again is like whatever was right last time. Like, oh really? So a couple episodes ago, where we left off was reading from Kunihiko Kodaira, and then this Oscar Zariski. And so Zariski, he had a great little quote, and what it was about was that something about that mathematics was like, it was hard to find some of these things at this time. So he said it was like a dessert. And I made a comment to the effect, is like, I'm pretty sure he meant desert. But I did find in a book the other day a counterbalancing typo. So I was reading a translation of Odysseus or the Odyssey, and at some point in time, there is a mention of a dessert, and it's spelled desert. So maybe in the matter of all the cosmic rays and whatever could be random, and come down and otherwise a usual edited work and textbook, you'll find it has no errors at all. None. It's entirely grammatically correct and accurate. And then we hope for something that's also full of symbols and formulary. These are a lot harder to verify sometimes, or easier. What is accurate, what is true, and all this kind of stuff. So in this case, maybe it just kind of balances out. But there's no guarantee or law of that at all. It's much more a fact that from reading a very wide array of things, like this book on Oscar Zariski, and a translation of the Odyssey, finally I happened to arrive at having enough input to be able to say, these two are part of the same world overall, where they are a complement to each other. Of course, one is just being a story, maybe a history, but mostly just for entertainment value. And the other one being, in a sense, a narrative about the development of these mathematical objects. But they're both kind of in the same world of things, in a world where they're the same. What else have I been reading? I've been reading Cervantes' Don Quixote, and it's great. I really enjoy this a lot because the Cervantes' Don Quixote is, and he's been discussed here a little bit before, and he's a knight errant, and Don Quixote of La Mancha upholds the very highest ideals of all chivalry, and the defense of all things of his time and place were considered proper, upright, and as of the highest order of individual character. So that's his worldview, and what the development of the story though entails is for sure is great. Is that his retainer Sancho Panza looks after him and comes to adopt also his attitude and opinion of knight errancy and the chivalry, and that chivalry is not dead. It's kind of like conversation. It's just curled up in a corner, kind of weakly kicking at things, but chivalry and courtesy are not dead, That so that's, and then the first part of the book is kind of up to where Quixote takes a fall or is struck down in one of his many defenses of his theoretical cause. That he finds himself back in the surrounds of his counterpane, as it were, which is a story about a person who is ill, and so they basically were invalid in their bed under the counterpane of their comforter, but they had their fantastic world, this diorama in front of them of their tin soldiers or something like that. So anyways, but then part two starts as because it had been issued as a serial, and so Cervantes starts writing it first of all, and he gives this great impression that someone had been writing unauthorized serials of Quixote, and not to be accepting those at all, and even though he would forgive them, that they would suffer great pangs of angst and retribution, and all this kind of stuff. And then he gets into that in the and I've only gotten about this far, that they're receiving the stories, and then as of the previous serial editions, inside the serial edition, as of at once. So it's kind of fun in that form of fiction to be then that it has already taken a place and a hold of its own culture. So I'm reading Quixote, and it's kind of devolved into it's a comedy, but it is it's a gentle comedy, and it has it's got a pretty thorough message to it, and a gentle message to it. So that's good. And I read a bunch of Ayn Rand and like the Atlas Shrugged and this and that. Now, on the one hand, it's like a setup for other dystopian type things, because it's just it's like about the whole dangers of we think, whether you can look to like the Marcuse, One-Dimensional Man, or Habermas in the Frankfurt School, or George Orwell in 1984, or this, what was it, Zabriskie or We, the Zamyatin's We. It's a in 1920s Soviet dystopian future where there was like this total plan by society's planners or the social engineers having figured out how to make a sort of unfair, inegalitarian, highly controlled environment that it worked out that it couldn't survive that way. It was unsustainable. And so the Iran picks up a lot of that and has this great opinion that the realized person is the most critical driver of change and development and productivity. And then we might say, well, you know, that the biggest, according to macroeconomics, the biggest dependable variable that can be driven, the biggest driver of growth is research and development. So in the big macroeconomic formula that is like the government's and all the gross products role in the economy, that the amount that goes into research and development, at least for 100 years or more, indicates how much real productivity and growth there will be. And that's the only real way that people can, you know, you can feed more people or house more people, or otherwise forestall the Malthusian dilemma, which we see so much these days, and problems with people wanting more resources when there's plenty to go around, besides wanting more resources when there's none. That anyways, near the end of those, there are quite a few spelling mistakes and errors that arise and show up. Or at least a half a dozen, which is quite remarkable in otherwise any kind of such work. So you wonder, did the editor just, you know, lose interest and just not read all the way through? Did the editor just figure that by this time I should just trust the author and the work they've submitted goes all the way through? The editor throw in some typos just to make sure that it didn't come across as some kind of perfect finished thing that is the result of all these production values vis-a-vis its authentic, true, unvarnished self. I don't know. You know, it's undefined behavior. I don't know. So reading this Zariski here, let's see. I'll be looking for a first and second volume. I found this second volume, but I haven't really absorbed to digest this. So this is where we got into Zariski and the Riemann-Roch theorem, and because this gets into the linear and the nonlinear things, it becomes a pretty general way to get above for the algebraic geometry's benefit, this and Riemannian. Then for the Lebesguean, Riemann and Lebesgue, their definitions of integrability, as we've discussed here pretty thoroughly in reading up after the formalization of the Fourier style analysis from González Velasco, that Kodaira really made it possible to have one of these first. So I'll be looking to try and figure out how to understand, to make for these integral equations, and from my perspective, this development as after the identity dimension, the hypergeometric and the regular singular as about out of that. So, as an aid to the casual reader, there's an interesting discussion, some open questions, Grout, Hartshorn, Hironaka, Matsumara R10. He says, he talks about the method of holomorphic functions. So this is sort of the introduction. This is the introduction by R10. So that we got to talking about the holomorphic functions and those being so general. Kind of like, well, the Hilbert space can be so general and that it's kind of like what's all for the complex plane and complex analysis that lives all out in that. Well, something like Kodaira was able to say, well, how about just forget that for a while, and I'm just going to make my fundamental theorems here, build out to that again, do the extra work that I don't really need to have borrowed de Moivre, Euler, and Gauss to get there and back from analyticity, because I can just build one of my own. So then these holomorphic functions are kind of like a little bit more of the same as that, if they can be so made great. Because the holo and then the morphic means that they have these multiplicities in their singularities. They have shapes. They're not amorphous. They're holes. They have they're singular in this sense. They're holo, meaning that they is of the holonomic, the holodromic, the hologram, the hologrammatic, or the holograph, that they come into as a projection inward into one again. These things that the holomorphic functions kind of affect to reflect these projections of a sort, and things we've been talking about here over a long time, or at least this 50 or 100 hours, like the geometric pencils, the items as of after the developments of Lefschetz, Picard, and the one forms and two forms of the algebraic geometry, but really just these pieces of the sheaves, as far as those being fungible from point sets all the way back up in that. These holomorphic functions, where function is given a rich definition, this kind of thing, that this introduction by R10 intends to entail that there are some further great things to get figured out from that. Three cups of coffee a day is a lot of coffee. What I've learned is that I really don't need 3 cups of coffee a day, but I often find myself pretty much drinking 3 cups of coffee a day. One time, there was this one given place, and what it was is that it had a kitchen canteen, and in the kitchen canteen, it had a coffee service. And so the way the coffee service worked is that there was just a bin full of bags of coffee grounds, and then there was a coffee brew machine and a decanter, or the carafe. So the idea was you could just come up and have as much coffee as you'd like. But if you happen to drink the last of the carafe, then it is upon you to refill the coffee maker. And thusly that the next person would come along and would not only be out of coffee, but also have to start from scratch and make this just like so. And then how that basically worked out is towards the end of the day, someone eventually would just like leave the lid up. And that would just mean it's like, it's empty, but if you really want more coffee, it's like after 5 o'clock, but you're welcome to do what you want. So anyways, one day I filled that up 8 times, which meant that I went for at least 8 cups of coffee. And, but really it was just a chance to stand up and walk away from the desk for 5 or 10 minutes, because each hour or so it was necessary to get up and walk away from the desk and to exercise the feet, because while the heart is so busy all the time pumping blood, and it has a major role, and everybody knows its central aspect in the circulatory system for thousands and thousands of years, or since history, it's always been known in the sense that how the circulatory system is and worked, that also the feet are very critical in keeping things moving, that the mere exercise of walking around the feet effectively acts as pumps that are necessarily involved in keeping the sedentary, like myself in that situation, from developing hypertension, edema, or other such sorts catastrophic health issues. So R10, here he says, the work on holomorphic functions, Summa Brasiliensis paper. So, algebraic geometry is emerging through the work of Weil, W-E-I-L, and Chevalier, on local rings and of Zariski himself, because of his interest in geometry in the large. Zariski quickly saw the importance of holomorphic functions along subvarieties, which he thought of as analogs of classical analytic functions. So in terms of finding how to apply things and then get them to relate and then be able to say that the transform exists between them, the completion of that so follows, that this continuous, the conservation is conserved, as via the symmetry and the invariance, they're kept so. These are the features that then, once he's able to describe this analyticity, then whether or not he needs the rest of complex analysis to do that is a different kind of thing. Again, just showing that these deconstructive accounts of these fields of mathematics can then offer inroads which have much, much greater swaths or regions which they can then be covered as vis-a-vis otherwise kind of keeping the entire circus tent up when somebody wants to come along later and just be able to use a numerical method that happens to be only defined for this one particular assumption of analyticity in the complex numbers, or the Eulerian and Gaussian. Again, I have there's much to be said for the great thing that is the de Moivre's theorem, and with respect to that and assigning to it like that a product of the imaginary constant I that square is -1, results having this feature that makes it for that the complex diagram has this other features of the rotations and the screw arithmetic and analyticity vis-a-vis the Wick rotation and all these things to do with the usual development. But it's contrived. It comes across as very contrived when you just say, hey, you're not really making the use of that the I is the square root of -1. -1's got lots of square roots, maybe. All you're saying is that I's square is -1. And then just for even and odd functions about a particular aspect of the trigonometric functions as they go around the quadrants and even and odd. Is it really that great with regards to why it is and just that happens to fall in the middle? There's nothing wrong with it. Don't get me wrong at all. But if that's like, the circus tent that kind of adds up to like, here's where this starts with this and those and these and it adds up, hey. There are other ways to go about it. And these are examples of Kodaira and Zariski that they don't really care so much, and they're kind of gently helping to advise us. Something like Lefschetz was like, we are algebraic geometers. Vis-a-vis, of course, you have to know how to do algebraic manipulation and formulas and all that kind of stuff. And that's the easiest and best way to solve most all things that are linear when there's enough information. Because of his interest in geometry in the large, classical analytic functions, this point of view was suppressed later in favor of viewing them as inverse limits, but we hope it may be re-emerging. We'll see R10 here helps to relay some of this controversy. Says we are just in favor of viewing them as inverse limits. And so this is about these completions and stuff like that. Kind of like, what about the integral formulas and the differential formulas and their solutions in terms of each other or not? But they're open singularities and multiplicities in terms of each other's or not. Here it was just put up as like, well, as Kodaira, for example, built up this thing, and Zariski had built up this thing, then it was like the great edifice of like, we are the Hamiltonians, and so don't get in our way, because we use the same code for every single thing, and it's like, so they're just like, well, it's true in the limit, we build a completion to it. We'll meet you in the middle of that. Vis-a-vis, actually, we from our perspective, it's like you're meeting us in the middle, because your Hooke's law that comes down for your Clausius-Clapeyron and then up for your Hamiltonian is classical, but it's also truncating at some point. And so what you've made is a numerical method, whether you noticed or not. These are the kinds of things that one gets into when trying to figure out how to thoroughly address what goes on to the foundations and get back up to where you can support the applied, because all these people who do work on these linear systems are like, I have no idea what you're talking about as soon as you said not what I know. Because all my schooling, 8 years of it, went right up into this, and that's the end of it. So trying to figure out, and it's like gently, how to relay. You got to be able to relay and basically deconstruct it each step and bring it on back, bring it on down and bring it on back. How then it can be said, you're going to get back out of it what you're still already getting out of it, and your error bounds and terms are still going to be the same for the same reasons. But then this other stuff, eventually you got to add in. You'll want to know why, and not just because you farmed it out to a hypothetical cloud clock cat on the internet whose embarrassment of resources is able to make 9 biscuits per coffee break. He's being introduced as theoretical, abstract, silly, hypothetical, theoretical computer science terms that affect a combination of you want it when, which is a traditional question expressing incredulity, and knowing where the food comes from, which is a traditional way to express that matters of knowledge representation are as of that, not they cannot be just accepted. So it's pretty exciting to read this about Zariski from Martin, because it helps to affect or reflect that there are lots of different little fields and schools in mathematics. And it's interesting and can make one, happy to think that at the same time there's this entire unifying thing, because mathematics has a language altogether that's universal and is the same for everybody in a sense, whether they know it or not, it's the same. And that also that all these different fields, when they are approached by the words that name them and give them their definition, that then they all have to kind of find each other, all these various and different ways. Then the kind of context is this, as we've had in the discussion here with regards to coming up from that the theory is ancient and antique, yet the same, and it's the same one we've always had, yet at the same time it's modern, and from all these different components and all these different contributors coming along in the stream, in the river, in the flow of the river, on the river, that these are the kinds of things that from this moment in motion point out that there's nothing really new yet so far about it, except that you can see now this idea of trying to come around from the little end of the infinite many higher orders of acceleration is a lot like Zariski's here and the inverse limit, how they're building these analytic functions. This whole idea of the concept of the theory of potentials, that the potential fields are the real fields, and that there's just one of them really kind of thing. And the idea of all the aspects of field theory in like a fall gravity, or this kind of coming back in together, super classical, adds back up. So you can see why for foundations, it's necessarily not so much all the canon and all the dogma and all the doctrine historically assembled from all time, that it still has to be that as well. And not just the latest, greatest data of all the science and all the things put together, and that it must be that as well. That then it has to find what's the missing link here between what we have finally been able to hammer out as at least a standard line coming up, called our formal foundation and our standard linear curriculum, and our rigorous mathematical formalism for a mathematical theory, and you can call it set theory and descriptive set theory and make a category theory from that if you care. You're welcome to. Right? I mean, this is the way that it is done. And there's one language of mathematics in regards to the deterministic, and that otherwise it's just pseudo mathematics of a sort. That then it's possible to kind of with a bit of a starting point and a bit of study to catch up pretty much to where it's so that this idea of a sum of histories, sum of potentials, least action gradient theory is a theory that the theory of everything must be. So I hope you had a great day today or this summer. It was kind of a cold summer. It's a little different than what I expected after the past 5 or 10 years of record high temperatures every summer, or at least here it was. I'm not sure what that means, whether it's just like a blip of kind of this leaps and bounds, or this hop, skip, and a jump, which are some of these concepts that get into the pseudo-momentum and the stop derivative and this kind of stuff. Or what? It's stellar dynamics, or that there are many more variables than what are the usual ones considered to affect the things, or less. These again, though, are beyond what is the subject discussion here, which is fellow Earthlings, moment in motion. Geometry is motion. There's one theory at all would be a great thing. So if you're going to figure one out, because everybody has to have their own, and then the usual idea is that people find the best one they can find that other people have and adopt it, or at least a theory of it. It's a theory of a theory of a theory of a theory. Paradoxes can only either be one or none. Contradictions, of course, are just something's mistaken. But paradoxes can be only one or none. And it has to be entirely logical, and it has to be entirely scientific. Good luck. Thinking people of all sorts have been making these up all the time, forever. Have a great day.